All right, students, so we're here and we're going to be utilizing a gizmo today. All right, you don't even have to do the gizmos yourself. I just want you to just visualize some things. Something I like about the gizmos is that you can physically see angles appear, move, how they relate, chords, all this fun stuff. All right, so we're going to be investigating the relationship of measures of chords, arcs, and central angles. And to begin, we're going to make sure one circle is selected under figure type, and under conditions, we're going to select congruent angles. All right, congruent central angles. Bada bing, bada boom. So what's the measure of angle CAD? All right, so let's go to show angle measure CAD. It was 45 degrees. All right. And what's the measure of arc CD? All right, so show arc tool, turn it on. So the measure of the arc, boom, 45 degrees. And something that's important, something we're going to be talking about later, or comparing and contrasting, arc measure is in degrees. Arc measure is in degrees. Later on, we're going to do an arc length. That's in like inches and centimeters. We're doing arc measure from the time right now. So how does the measure of arc CD and the measure of arc CAD compare? Well, they're the same, all right? And we knew that to be true already. And that's true for any, I can change this arc, so on and so forth. It's the same. All right, so now, first draw circle A with diameter CK and LD. All right, so we're just gonna draw what we see over here. So I got some random circle. This is circle A. And drawing diameter DL and diameter CK. All right. All I did was draw what I have. All right, and look at the congruent central angles CAD and LAK. What appears to be true about the arcs that the angles intercept, arc CD and arc LK? Well, the central angles are congruent. Thus, it appears that the, I'll just write it right here, arc, and let's write this. We'll phrase it like this: intercepted arc. Sometimes you'll read, instead of saying arcs, we're going to say intercepted arcs are congruent. And not just saying this right here, like CD is an intercepted arc. LK is an intercepted arc. All right. And we'll even write that out. It appears arc CD is congruent to arc LK. And what appears to be true about the measures of the central angle? Well, we already picked that they're congruent, but let's just verify it with this angle measure tool. So it appears that they have the same measure, which is in fact true, because something I want you guys to realize is that angle CAD is congruent to angle LAK. These central angles are congruent. Right now, they are vertical angles. All right. All right, vertical angles. That's just in the specific case. Central angles don't always have to form vertical angles, but right now they do. All right, so let's keep cruising right along. Under conditions, we're going to select congruent arcs. All right, select congruent arcs. All I did was read that right here, congruent arcs. On the figure on the right, sketch the central angles that intercept these arcs. All right, how do you think these central angles are related? All right, so basically all it's saying is arc DC is congruent to arc KL. And it's saying draw the central angles. So can I do this? No, it won't make it perfect, darn it. Stupid notability. All right, so we have this angle and this angle. All right, now, how do you think these central angles are related? I think that they are congruent. All right, I'm going to predict angle DAC is congruent to angle KAL. All right, and let's use the protractors to check. So we'll show angle measure tools again by doing this. And this angle is going to be 42.97. Let's get another show angle measure tool. And 42.97. So we were right. Smiley face, because we were borderline geniuses. All right, so now let's complete the if and only if statement to describe how central angles and arcs they intercept are related. We have this theorem. It's the congruent arcs theorem. All right. Intercepted arcs are congruent if and only if their central angles are congruent. All right, so basically this big punchline, visualizing, seeing how if arcs are congruent, their central angles that intercept those arcs are also congruent. So that definitely exists. All right, let's keep cruising right along. Now we're going to select congruent chords. All right, so DC, let's just remember DC and KL are what we call chords. All right, and if you forget what a chord is, it's a segment with end points on circumference. Kind of ran out of room to write circumference. Oops. All right, but that's what they are. They're circumference, or they're chords. Their endpoints are on the circumference. That's all we selected so far. All right, now we're going to sketch the central angles intercepted by these chords. All right. So how do we think that these central angles are related? So we got this bad boy right here, and we got this bad boy right here. All right. How do I think that these are related? I'm going to say congruent. I'm going to predict that again. I'm going to predict that angle DAC is congruent to angle KAL. And also something, remember, this is the notation when you see these little arcs right here. That means congruent. Don't you forget that. All right, now let's check. Let's show angle measure. Let's actually make the angles, and bada bing, bada boom, they were both 100 degrees. I was right. Hooray me, I'm so smart. All right, so that's it again. So if chords are congruent, their central angles are congruent, and then we can even write like a side effect, arc DC will be congruent to arc KL. So not only, because then we're just using the other theorem. So like that arc and that arc. So chords, arcs, central angles, all congruent. All right. You might say, well, duh, that's obvious, but sometimes we're just emphasizing things visually, seeing it move in the gizmos. This is what I really like about this. All right. So let's focus on this figure in the right. Make this a little bit bigger. All right. So chords CD and LK are congruent. So tick mark, they're congruent. How do we know that AD, AC, AK, and AL are all congruent? All right. How do we know all of those are congruent? Well, they're radiuses. Radii. Sometimes I just like to write radiuses. Who knows how many S's end at the end of word radiuses? All right. All right, and then some fun fact is, how do we know that triangle CAD and triangle LAK are congruent? Well, it's side, side, side. All right, look at this triangle. Both triangles have three, or the corresponding sides of both triangles are congruent to the other corresponding sides. So we know they're congruent by side, side, side. All right, which we can call SSS, but I felt like writing that. How does this prove that the central angles are congruent? Well, you could say vertical angles, or we could also say corresponding parts of congruent triangles. That says triangles. Sloppy handwriting. Let me rewrite that word. Corresponding parts of congruent triangles are congruent. All right. And then right here, two chords are congruent if and only if their intercepted arcs are congruent. All right. And we're going to pause here and pick up the gizmos in the next video.